Hello, class. Welcome. After so many days without class, we're going to begin the stage number 3, which is about linear equations in 1 and 2 variables and fractional equations. And today we're going to look at the main terminology and the main definitions of this stage. Even though, since I already told you to read a little about this, you should be somehow familiar with these ideas already. But I want to give the class also. So let's start. The first thing, what is the definition of an equation? Well, it's not a very hard definition. It's a very simple definition. So I'm just gonna say it. I don't need to write it down. A definition of an equation is an equality between two quantities. It's that simple, okay? An equality between two quantities. For example, if I write something like this is one quantity, right? And when I write this symbol and another thing on the other side, which is another quantity, then this is an equation, right? Because it's an equality between two quantities. Okay, it's a very simple definition, extremely simple. Whenever you see this sign in mathematics, you're talking about an equation. You're saying that something is equal to something else. It is that simple. Okay, the only thing that I want to remark about this definition, guys, is the following idea. One very common mistake from mathematics students is to call everything an equation. Okay, for example, a lot of people, when presented to something like with something like this, okay, 6x squared minus 1, a lot of people are going to try to call this an equation. Okay, they say, oh, look at this equation, 6x squared minus 1. That is wrong. That's not an equation, right? This is an expression. If you don't see the equal sign in your in your writing, you're not talking about an equation. Okay, so that's just a very common mistake that a lot of people do and don't make it. This is an equation. I'm saying that this is equal to this equation. If I just write this is an expression. Okay, and that's all we have to say about an equation. I mean, about the definition of an equation. So the first point, done. Now the terminology, I need to give you some vocabulary and I need you to use this vocabulary, okay? Get used to this vocabulary. It's 6 terms. They are extremely simple, so you're gonna memorize them quite quickly, right? For example, let me give you an equation. Okay, look at this equation. The terminology for this equation and all other equations is the following. For example, the left side of the equation is clearly this one, left side. The right side of the equation is this one. The equal sign is this one, equals sign. Okay, you see how simple it is? Variable. Now I'm going to erase what I wrote. Left side, right side, equals sign. Now the variable. What is the variable? Well, in this case, it's x. Okay, this is my variable. What if I write some other equation like so? 2 to the square minus y. Okay, as you can see in here, my variable is y. In here, I have an equation with 3 variables, okay? Y, z, and w. This is a number 2. You know, when I write the letter z or the variable z, I do it this little line in between, okay? So as not to confuse it with the number 2. So this equation has one variable, which is x. This equation has only one variable, which is y. And this equation has 3 variables, which are y, z, and w. So that is the variable, right? It is a number that you don't know. You do know the number 6. That is a constant. You do know the number 1. the number minus 4, etc. The only number you don't know about here is the x, and that's why we call it variable or unknown. Okay, that's, you can call it also unknown. Uh, in the book, if you read it, if you read what I told you to read, uh, the book said that you can call a variable an incognita, and that works. Variable, also known as unknown. Okay, yeah, I was telling you, the book said about this word incognita. This works only in Spanish, guys, incognita. But in English, we never say this word, okay, for a variable. We either say variable or unknown. We never say incognita in English. So I've told you quite a few times already, do not trust very well. Do not trust the book so much because it has a very poor translation, in my opinion. Okay, so one, two, three, four, number five, number six. Solution or root of an equation. Solution and root are synonyms. They mean the same. And what are those things? Okay, let's see. What if we have this equation? 6x minus 1 equals 11. When you find the number, so that when you put that number instead of the variable, okay, when you substitute that specific number in the variable and the equation is satisfied, then we say that that number is a solution or root. For example, in this case, that solution or that root, as we know, since this is very simple to solve, sorry, it's 2. If I give x the number 2, okay, the value of 2, we can see that we get this, right? And so my equation is satisfied. We say this in mathematics, satisfied. When I give x the value of 2, my equation is satisfied. And therefore we call 2, the number 2, we call it the solution or root. The root or solution is x equals 2. The root or solution to my equation, okay? In this case, is the number 2. So remember, root and solution mean the exact same thing. Okay. What if I gave x the value of, let's say, 3? Let's do that. 6 times 3 minus 1 equals 11. So I have 18 minus 1 equals 11. So I have 17 equals 11. This is clearly not true, right? And so we say that 3 is not a root or solution to my equation because my equation is not satisfied when I substitute x by 3. Very simple ideas, extremely simple. But I need you to understand this very clearly and to make use of this terminology, okay? Make use of it. It's kind of like the ABC of the equations because, for example, when I have um, mostly in class, when we have real classes, and if I write an equation on the whiteboard, something like this, okay, we're working on this equation. A lot of people tell me, teacher, what is that number on there? And they just point me, right? Like, what is that number there? And they point me somewhere, and I go like, where? I mean, like, you have to tell me where exactly. So contrast this idea or this way of addressing me with this other perfect way. What if you tell me, teacher, what is the number on the first term of the expression on the left side? Even though it looks like a lot. Let me repeat that. Teacher, what is that number, or let's say, what is that coefficient on the first term of the expression in the left side? So that student is talking about this. This is the coefficient or the constant in the first term of the expression in the left side of the equation. You see? So it takes a lot of time to get used to talk like this because you're going to be talking like a machine on a computer. But that's much better than just pointing me somewhere and being completely vague about what you're saying. It is better to talk in this computer language, so to speak, like be very precise. Like, teacher, what happens if I eliminate the second term of the expression on the right side? So I'm talking about this, right? Etc. Okay, try to get used to that as quick as possible. You have to talk mathematics. It's a language, guys. Well, it's many things. One of them is a language. And the final uh, concept or term is this, the concept of a solution set. What is that? Okay, for example, another very quick and easy equation. X plus 2 equals 4. What is the solution to this equation? We know it, right? It's very simple. The root is x equals 2. Very simple thing. And so we say that the solution set, and that's written with an S, the solution set is equal to this. Okay, I'm not going to explain you with a lot of detail what these symbols mean here, these braces. I'm not going to do that because it falls out of the scope of this explanation. All I'm telling you is this. All I need you to understand is this. The solution set is kind of like a box. You can think of this as a box, okay? A box in which you're going to put all your solutions. The solution of this thing is 2, so put it there and write it like this. Okay, you can think of these two braces as a box, and you're going to put all your solutions in that box. I repeat, the solution set is equal to 2, the solution set of this particular equation. Let me give you another example. What if we have this other equation, a more complex equation? Let's say x squared equals 9. Why is it more complex? Because it's raised to the square, right? Okay, when we solve this equation, what we do is we take the square root in both sides, and the square root of 9 is both 3 but also minus 3, right? Because 3 times 3 is 9, and because minus 3 times minus 3 is also 9. So this equation, guys, has two possible solutions or two possible roots, 3 and minus 3, and both are perfectly fine. No, not one is better than the other, okay? So what is the solution set for this particular equation? Well, my solution set is equal to 3 and minus 3. So I separate my roots or my solution by commas. You see? So this is the solution set for this particular equation. And there are many more. Then there are equations that may have 3 solutions. So you're going to see something like this. For example, you could see something like this, 2, 1, and 5, etc. Okay? So that's how the solution set works. It's a box in which you're going to put your solutions separated by commas. That's all you need to know by now. Okay, and that's all the terminology, guys. For when we talk about equations, use it. Get used to call things by the proper names. Okay, left side, right side, equal sign, variable, solution, or root, and solution set. Get used to these things and pronounce them as much as possible. Okay, number 3. What is a linear equation in one or more variables? What is a linear equation? What does a line have to do with an equation? Okay, so a linear equation is something like this, guys. I'm going to give you several examples. This is a linear equation, another linear equation, another linear equation. Okay. Okay, let me stop right here. So what do you observe? But okay, let me contrast this. These are linear equations. This is a linear equation, linear equation, linear equation. This is not a linear equation. Okay, this is not a linear equation. Let me give you another example. now with y. 3y to the cube minus y to the square minus 1 equals 4y. This is not a linear equation. So what is the difference here? What's happening here? Okay, if you see, we are calling linear equations when to the equations whose variables are only raised to the first power. For example, x, remember that when we don't put an exponent in here on top, that's because it's a 1. So all these variables, all the variables appearing in your equations, in the first three equations, are raised to the first power. Okay, and that's why we call them linear equations. Okay, you may say that we call a linear equation an equation whose variables are raised to the first power only, and all of them. Okay, if you have something like this, 2x squared plus 3x equals x minus 1, even though this one and this one are raised to the first power, as long as one doesn't satisfy that requirement, then this is not a linear equation. All of the variables have to appear raised to the first power. And that's why this equation is not a linear equation because of this. And that's why this other equation is not a linear equation because of this and because of this. So that's the definition of a linear equation. It's an equation whose variables are raised to the first power. All of the variables. All of the variables. This takes too long. All right. Now, let me write this. This is a linear equation in one variable. What is the variable here? Is y, right? So that's why we say that it's a linear equation, because the y is raised to the first power, and it's an equation in just one variable because you only have one variable, which is the y, right? Now, what about this? 2x minus 3 times 2 minus y equals 2x plus y. Is this a linear equation? Yes, because all the variables are raised to the first power. That's clear. So this is a linear equation, but in how many variables? We have two. We have x and y. So this is a linear equation in two variables, which are x and y. Perfect. Now example, 3x minus y plus 2 equals z plus x. This is a linear equation in three variables. Linear equation in three variables, which are x, it's right there, y, which is right there, and z, which is right there. Okay, so that's how it works. So third concept finished. And finally, the fourth concept, I'm going to tell you about the different types of equations, different classifications that we have for equations. And this may be, in this class, this is going to be the hardest part to understand, but it's not really that complex. So we have three different types of equations. We have conditional equations, identity equations, and inconsistent equations. So let's see what that means. The most common, or the ones that you know the most, are conditional equations. For example, when I write something like this, let me write here conditional equations. For example, if I have something like this, 3x minus 1 equals 5. Okay, try to give me the solution to this equation quickly in your mind. It's very simple. What is the solution, guys? The solution is x equals 2, right? Because when I put 2 in there, I get 3 times 2, 6, minus 1 is 5. So it's going to check, right? And we say that the solution set is just 2. Okay, why do we call this a conditional equation? This particular equation, why is this a conditional equation? Because only specific values specific values of x or your variable satisfy the equation. Satisfy the equation. Only specific, okay? In this case, it's only the number 2 that is going to satisfy this equation. If you replace x by any other number, and you can make the experiment if you want, by any other number in here, you're not going to satisfy the equation. You see? So you may call these equations, I don't know, picky or choosy, okay? Only some only some values for the variable will satisfy the equation. So that's why they're called conditional. Now, the other type of equation is identity equations, or just identities, right? Let me just write that. Identities. Okay, what is an identity? It's also an equation, but it's something like this. For example, I have already taught you that when we raise a binomial to the square, we get, in this case, we're going to get this, the square of the first number plus twice the product of the first times the second, plus the second number to the square, which is just 1. Okay, so x plus 1 to the square is equal to all of this. Now, the thing with this equation, guys, because it's an equation, right? You have the equal sign in there. The thing with this equation is that it's an identity. And what that means is that when you replace the x, for example, I don't know, if we put the number 2 right there, 2 plus 1 squared is going to be equal to 2 squared plus 2 times 2 plus 1. How much is this? This is going to be 9, right? And how much is going to be this? It's going to be 4 plus 4 plus 1. That's going to be 9. So the number 2, when I replace this equation, the variable, by the number 2, it checks. So the number 2 is part of the solution set. Now, do that, guys, with any other number you want. It doesn't matter. It doesn't matter. What about minus 1? I'm going to replace x for minus 1. So here we go. Here it goes. Minus 1 plus 1 squared equals minus 1 to the square plus 2 times minus 1 plus 1. This is 0. This is going to be 1 minus 2 plus 1. So this is 0 equals 0. Another check. So the number minus 1 is also a solution to this identity, etc., etc. Any number, any value of x, any value, it doesn't matter which one, is going to satisfy this equation. So in the solution set, I have all possible real numbers. Any number is going to satisfy this equation. And that's why it's called an identity. What we are saying basically is that the left side, which is this, is identical to the right side, identical for all possible values of x, all of them, without exceptions. And that's what an identity is. And some people use, when they talk about identities, some people write another line in here, okay? So in order to say that this is even a stronger type of equation, it's not just a conditional equation, it's an identity. This is true for every possible value of x. But I don't like to use it. And most mathematicians, to my knowledge, most mathematicians do not use it. But just don't get scared if you see something like this, okay? What this means is identity. Okay, perfect. And the final type of equation is an inconsistent equation. What is that? What is an inconsistent equation? Well, something like this. For example, what if I write x equals x plus 8? This is clearly an equation, right? Because I'm saying that something is equal to something else. At least in principle, okay? I'm saying that this is equal to this. But this is an inconsistent equation because when you try to solve it, let's see what happens. For example, I can do this. I can subtract x from both sides. So I'm going to get x minus x equals x plus 8 minus x. You see, I'm just subtracting x from both sides. And what you're gonna get is this 0, x minus x is 0, and then x minus x is gonna be 0 plus 8 is gonna be 8. So you're gonna get something like this, guys. Look at this. 0 equals 8. I started with this equation, and then I followed some logical process. I subtracted x from both sides, which is perfectly valid, and I arrived at this conclusion. I arrive at the conclusion that 0 is equal to 8, which is clearly a contradiction. Contradiction. It's not true that 0 equals 8. So what this tells me when I arrive at a contradiction, what this tells me is that my original equation was inconsistent. Okay? Basically, the author of this equation, in this case me, I wrote this equation, I wrote an inconsistent statement. Okay, I wrote something that cannot be solved. I'm saying an impossibility. I'm saying that some number is equal to itself plus 8, which is perfectly impossible, right? It's not possible that a number is equal to itself plus 8. You see? So that's what is known as an inconsistent equation. Whenever you have an equation and you work it out, and at the end you find a statement like this, a statement that is obviously false or a contradiction, you can say that the equation that you started with is inconsistent, an inconsistent equation. So that's how oh, and by the way, if it's an inconsistent equation, that means that the solution, okay, let me write it down again. If I tell you, guys, please solve this equation, and you work it out, and you go like, teacher, we arrive at a contradiction. Okay, so this is an inconsistent equation, inconsistent, and your solution set is this, nothing. You see, there are no solutions for this equation, no solutions, or no roots, no solutions, no roots. Okay, so that's the solution set for an inconsistent equation. The solution set is an empty set. There are no solutions in there. Okay, so that's how this works, guys. That is the basic terminology behind equations.